a, and mainly the energy of some rigid body. And we have also used the concept of rolling without slipping and pure rotation, isn't it? हम लोगों ने लास्ट क्लासेस में ऐसा किया था, ठीक है? So today I will just work for angular momentum, and then next class we will just go for torque. So angular momentum and torque both are more or less same thing. So there is not any big difference. So first let's try to go for angular momentum. Obviously rate of change of angular momentum is torque. So you know all this thing. Okay. So but if the rate of change of angular momentum is 0, then angular momentum is conserved. So what is torque? The definition of torque is just you can go for dl upon dt, and this will equivalent to what? R cross F. This is equivalent to what? R cross F. Okay. And F is the force, and this is R cross F will be torque. But if you have in some case, and obviously if you are talking about torque, you are just talking about which axis. Suppose you are getting about some axis, you are finding some axis about which torque is 0, then what you will get? You will get angular momentum is conserved. So if torque about any axis, so axis is very important, is 0, then dl upon dt is equal to 0, which implies angular momentum is conserved. L is conserved. Okay. Now, this is a basic definition of torque and angular momentum. So what is angular momentum for the rigid body? So now, again, we will go for a same concept we are using for the energy, mainly the kinetic energy. So you have to consider the center of mass, and after then you have to consider the rotation of a rigid body. So suppose I am just talking about any sphere, and this is your sphere, and I just want to, and this is my axis of rotation, and this is my origin. So, and this is my center of mass. I just want to write angular momentum about this particular point. So this is some sphere which has some moment of inertia, and it is just going to rotate something like this, as well as it is just going to move with center of some velocity of center of mass, and let's say its angular velocity is omega. Suppose this kind of situation is there, and this is my origin. So what will happen? You can have a radius vector from origin to center of mass. This will be your center of mass. Let's say this is your r vector. Okay. So what is your angular momentum? And at this point of time, when you have this sort of configuration, the angular momentum L can be written as R, or you can write M R cross VCM plus ICM omega. Now R cross VCM, so it is going downward, and omega is again, so I can just go for plus sign here. So you have to take care of this particular direction. Again, I am saying this is R cross VCM. So you are just crossing VCM. So this will be in this direction, and you are rotating as like angular velocity. So angular momentum is in this particular direction. So this is the complete in definition of angular momentum. And obviously, if you have rolling without slipping kind of situation, and then you can easily use the concept. What is rolling without slipping? Class में बताया था. VCM is equal to what? Omega R. So this is a condition of rolling without slipping. Now the if you want to apply the conservation of angular momentum, and we will do some problem, then insight will develop after then. If you are just going to apply conservation of angular momentum, you have to find a axis about which torque is 0. So this is very interesting. If your torque about that particular axis, if torque is not going to 0, then obviously it will create a havoc. But sometime you will find that 2 points can be equivalent point. For example, here I can take something like, if I am talking about this particular point, and if it is going for rolling without slipping kind of situation, so what is M R cross VCM? Can I write M mod R mod VCM into cos of the angle between this thing? Yes, R and VCM, isn't it? And what is R? Sorry, sine theta, not cos. That will be sine theta. R cross VCM. And what is R sine theta? What is R sine theta? This distance.
Radius.
And this is nothing but the radius. So can I say this value is M R VCM? लिख सकते ना? Plus you can just go for ICM into omega. Now you can see this point, if I am just trying to write the angular momentum about this particular point, then what will be angular momentum about this particular point? क्या होगा जरा बताइए? Same notation से आप अगर देखना चाहते हो तो? Anybody tell me? Here, the angle between R and VCM is what? 90 degree? Yes or no? अगर मैं origin को उठा के यहां से यहां कर दूं, then what is going to happen? Suppose you have this kind of situation and your origin is here. So this is your VCM. Now what is your R here? बताइए क्या होगा? M. What is your R?
Capital R.
Capital R. And VCM is there. And what is angle between R and VCM?
90 degree.
90 degree. Plus you can write ICM omega. And ICM will be always same. That is, you have to take the moment of inertia about center of mass. So that will be for the sphere, this value is what? 2/5. है ना? कितना होता है? 2/5 mr square for the solid sphere, isn't it?
Yes, sir.
Yes. So now you can see, sometime your problem will give you leverages that you can treat 2 points as a equivalent points. ऐसा कर सकते हैं ना? इस पॉइंट के अबाउट और इस पॉइंट के अबाउट एंगुलर मोमेंटम हमारा क्या आ रहा है? सेम आ रहा है ना? जस्ट लुक एट हियर.
Yes, sir. Yes, sir.
है ना? So you can treat this point and this point as an equivalent point because you are getting the same angular momentum. Okay, and now you can work for this type of problem, and this is one of the very famous problem for your examination. Okay, let's try to go for one basic problem. एक problem करने की कोशिश करते हैं. चलो. So what we have a sphere whose center of mass is moving with velocity v0 and which has angular velocity v0 upon 2r. Suppose this kind of situation is there. Angular velocity is v0 upon 2r. And this is your, and it is just moving ahead. And obviously there is friction. If there is not any friction, it cannot rotate. Now, after some time, it will achieve the condition of rolling without slipping. It will achieve the condition of what? Rolling without slipping after some time. It is just rolling, and after then its velocity is going to change, but it will just try to find the condition of rolling without slipping. So what is rolling without, if the center of mass has velocity vcm, what will be condition, what will be omega? What will be
by R.
omega?
VCM upon R.
Very good. So that value is, omega is your vcm by r. This is your omega, vcm by r. Okay. Now, so we have to calculate the value of vcm in term of v naught. So you have to calculate the value of vcm. What is value of vcm? How you can approach this particular problem? Can you approach the conservation of energy here? Use conservation of energy? यूज कर सकते हो कंजर्वेशन ऑफ एनर्जी?
No, sir.
No. Why not?
Friction. Because of
Friction is there, so you cannot use conservation of energy. So obviously, conservation of energy is not your piece of cake. है ना? So now we can go for, और क्या conservation of linear momentum से काम चल जाएगा क्या?
No, sir.
No. तीन ही चीज तो यूज करते हैं, कंजर्वेशन ऑफ लीनियर मोमेंटम, कंजर्वेशन ऑफ एनर्जी एंड कंजर्वेशन ऑफ
Angular moment.
angular momentum. Very good. Now, if you want to apply conservation of angular momentum, you have to choose an axis about which external torque is 0. Yes or no?
Yes, sir.
Now the whole challenge is that about which point external torque is 0. चलो देखते हैं इस तरह के प्रॉब्लम में किस पॉइंट के अबाउट एक्सटर्नल टॉर्क आपका 0 हो रहा है. क्या एक्सटर्नल टॉर्क सेंटर ऑफ मास के अबाउट 0 हो रहा है? Is that external torque is 0 about center of mass?
No.
पहले देखते हैं फोर्स क्या क्या लग रहा है ना. एक फोर्स तो mg लगेगा. यस. और दूसरा फोर्स क्या लग रहा है? बताओ.
Friction.
फ्रिक्शन. वेरी गुड. सो फ्रिक्शनल फोर्स इस डायरेक्शन में लग रहा है. ठीक है. नाउ अब ये एक्सिस ऑफ रोटेशन है. सपोज दिस इज योर एक्सिस ऑफ रोटेशन. सपोज मैं क्रॉस करके दिखा रहा हूं. दिस इज योर एक्सिस ऑफ रोटेशन. व्हाट विल बी टॉर्क ड्यू टू mg? बताओ.
0.
0. Why?
Passes through the point.
Very good. Because it is passes through the point and r and mg are parallel to each other. है ना?
Yes, sir.
Yes. So mg के कारण तो टॉर्क 0 हो रहा है. So torque due to mg is 0. Now friction के कारण टॉर्क होगा क्या?
Yes, sir.
Yes या no?
Yes.
Yes.
Yes. So friction के कारण यहां हमें टॉर्क लगेगा. So obviously center of mass is not a good point to find, to use the conservation of angular momentum. So अब ये बात है कि किस पॉइंट के अबाउट हमें टॉर्क लेना चाहिए. इस पॉइंट के अबाउट टॉर्क लोगे तो क्या होगा, जरा देखो. फिर से mg के कारण तो टॉर्क नहीं लगेगा, लेकिन फ्रिक्शन के कारण टॉर्क लगेगा। इस पॉइंट पर लोगे तो क्या होगा? एनी अनदर पॉइंट इस पॉइंट पर लोगे तो बताइए। यहां तो दोनों के कारण टॉर्क लगेगा, है ना?
Yes, sir.
Now, if you are just going to see this particular point, what will be your torque? Point of contact. Point of contact के about torque क्या होगा? जरा देखो तो।
0.
0. So, you have 0 torque about point of contact. Yes? So, angular momentum किस point के about आपको conserve करना है?
Point of contact.
Point of contact. ठीक है? So, we can write this as my O. Origin और इसके about, इससे जो एक्सेस पास कर रही है उसके about हमें angular momentum conserve करना है. So first we will write the initial angular momentum. So what will be initial angular momentum? Li दे रहा हूं. What is this particular thing? बताइए क्या होगा? M कैपिटल से दे रहे हैं. M is mass. R cross VCM plus ICM ओमेगा. यही तो डेफिनेशन लिखोगे आप, है ना?
Yes, sir.
ओके, क्लियर है ये? जस्ट अ मिनट. चलो. Now, what will be R here? What will be R here?
Radius of
Capital R.
Radius. What will be VCM is your V naught, है ना? What is angle between VCM and R?
90 degree.
Sin 90. Okay. Plus, what is ICM? बोलो.
2/5 MR square.
Very good. 2 by 5 M R square. What is omega? It is given V naught by 2R. So क्या आ रहा है? जरा वैल्यू देखो कितना आ रहा है. What is this value? M R V naught plus, what is this value? 2 by 10 na? M V naught R. So that value is 12 by 10 M V naught R. ये होगा initial angular momentum. So this is your initial angular momentum. Now you have to go for a final angular momentum when you are just achieving the rolling without slipping. So I have to find the angular momentum about this particular point. So this particular point and this point is equivalent point. Yes या no? अभी तुरंत दिखाया था. आप इंटरेस्ट लूज कर रहे हो.
Yes,
Please
sir.
respond.
Yes.
है ना? So let's try to go for LF. What will be this value? M R cross VCM plus ICM ओमेगा. इस पूरे चीज को क्या लिख सकते हो? M R VCM. And what is ICM? 2 by 5
MR
MR square. And what is omega here?
VCM by
Mhm.
TCM by
Very good. So that value is VCM by R. And next what you will do, you can easily go for this particular calculation. क्या होगा जरा देखो तो. 7 by 5 आ रहा है.
Yes, sir.
M R VCM. And now, hence about this point, there is not any external torque. So Li is equal to LF. So what is your answer? 7 by 5 MR VCM is equal to 12 by 10 यही हो रहा है ना, m r v naught. So what is your VCM? क्या आ रहा है?
6/7 V naught.
So this will be 6/7 V naught. One of the very popular question, very smart question. You can easily calculate your VCM is equal to 6/7 V naught. Very simple but very conceptual, and you can easily use this type of problems. आराम से आप इस तरह के प्रॉब्लम को कर सकते हो. ठीक है? Now let's try to go for another problem. याद क्लियर है?
Yes, sir.
Okay.
Yes, sir.
Now this is very interesting. इसको जरा देखते हैं. So there is a rod in a horizontal plane. Vertical plane नहीं है. कहां पर है ये? Horizontal plane पर है. So there is a rod in a horizontal plane, and this is your center. The whole length of rod is A, and the mass of rod is M. Okay. So this is in horizontal plane. आप टेबल पर एक रॉड रखा हुआ है ऐसे करके, ठीक है? And what will happen? A particle of small m with velocity v naught collide at distance a/4. कितने डिस्टेंस पे कोलाइड कर रहा है? a/4. After the collision, look at here. After the collision, m will stop and rod will move. क्या हो रहा है? आफ्टर द कॉलिजन m रुक जा रहा है और रॉड कुछ मूव करना शुरू करेगा. एंड व्हेन इट इज गोइंग टू मूव, इट हैज सम लीनियर वेलोसिटी एज वेल एज सम एंगुलर वेलोसिटी. सो इसमें क्या होगा? सम लीनियर वेलोसिटी और सम एंगुलर वेलोसिटी है. सो व्हाट यू हैव टू डू, you have to calculate what is your VCM and what is your omega. आपका VCM क्या होगा और ओमेगा क्या होगा? Now, can we use conservation of linear momentum here?
Yes, sir.
ठीक है, दो निकालना है, VCM भी निकालना है, ओमेगा भी निकालना है. Can we use conservation of angular momentum?
Yes, sir.
About which point?
Point of contact.
Only that point or any point? There is not any external force. Don't worry.
Yes, at any point.
यहां पर कोई भी एक्सटर्नल फोर्स नहीं है, और जो भी फोर्स ये इसके ऊपर लगा रहा है, दैट फोर्स विल बी ट्रीटेड एज अ इंटरनल फोर्स, बिकॉज वी आर ट्रीटिंग दिस मास एंड दिस रॉड एज अ कंबाइंड सिस्टम. सो जो भी इंपल्स फोर्स है उसको अपोजिट डायरेक्शन में उसको बैलेंस कर रहा है. सो दैट कैन बी ट्रीटेड एज बेसिकली इंटरनल फोर्स. सो व्हाट विल हैपन? You can treat conservation of angular momentum about any point. मैं यहां सेंटर ऑफ मास के अबाउट करूंगा, आपको मैं होमवर्क किसी और पॉइंट के अबाउट दूंगा, एंड यू हैव टू डू दिस थिंग. ठीक है, चलो. सो फर्स्ट तो हम लोग क्या कर लें? कंजर्वेशन ऑफ लीनियर मोमेंटम. एंड व्हेन यू आर गोइंग टू यूज कंजर्वेशन ऑफ लीनियर मोमेंटम, यू कैन ट्रीट दिस रॉड एज अ पॉइंट मास. आप इस रॉड को क्या ट्रीट कर सकते हो? एज अ पॉइंट मास. सो व्हाट विल हैपन? m v naught plus m into 0 is equal to m into 0 plus m into VCM. होगा ना? सही लिख रहा हूं?
Yes, sir.
What is this thing? This thing is nothing but conservation of
Linear momentum.
linear momentum. So from here you can get m VCM is equal to m V naught by m. Now I am just trying to calculate I am just using conservation of angular momentum about center of mass. So this is my center of mass. Don't worry. This is my center of mass. This is my center of mass and this is my origin. Now, what will be angular momentum of a system before collision? बताइए क्या होगा?
M V naught A by
M
4.
V naught into A by 4. Because angle between V naught and this R is equal to what? Remain same. Basically आप ये use कर रहे हो, don't worry. ऐसे ही लिख देते हैं. M R cross, sorry, ये तो particle का है ना? So that will be M V naught into A by 4. ये तो simple है. इस direction V naught है and this direction में R है. And what will be angular momentum of this rod before collision?
0.
0.
Before collision,
Okay.
0.
0. Now, what will be angular momentum of a particle about this point after the collision?
0.
0. Now, what will be angular momentum of rod? वो क्या लिखेंगे? M R cross VCM plus ICM ओमेगा, क्योंकि ये रिजिड बॉडी है. रिजिड बॉडी के लिए आपको रिजिड बॉडी का यूज करोगे, है ना? सही लिख रहा हूं या गलत लिख रहा हूं? नाउ जस्ट टेल मी व्हाट विल बी R क्रॉस VCM. क्या होगा ये? Just tell me what will be R cross VCM.
Sir, angle will be 0 degree.
A by
Angle
4.
will be 0 degree. So sine 0 is 0.
0.
है ना? This distance. Okay. So this will be 0. So this will be 0. What is ICM?
ML square by 12.
MA square by 12 into omega. And you can easily calculate the value of omega. What is this value? 3 m V naught by capital M A. ठीक है ना? So this is your answer. That's it. Now अगर आप इस पॉइंट के अबाउट अगर एंगुलर मोमेंटम कंजर्व करते हो, देन हाउ यू विल अप्रोच? जरा बताइए. अगर उस पॉइंट के अबाउट एंगुलर मोमेंटम लेते तो कैसे अप्रोच करते? फर्स्ट वाला क्या हो जाएगा जरा बताओ. इसको मैं हटा रहा हूं, है ना?
सर
बताओ क्या होगा.
सर ये आर क्रॉस VCM है ना?
तो क्या हो जाएगा फर्स्ट वाला? M
V naught
V naught
A by 4.
A by 4 प्लस A by 2, ऐसे करके जानबूझ करके लिख रहा हूं. ठीक है ना? बिफोर कॉलिजन.
Yes, sir.
ठीक है. A by 4 प्लस A by 2 जानबूझ करके ऐसा लिख रहा हूं. डोंट वरी. आफ्टर द कॉलिजन 0, पॉइंट मास का तो 0 हो जाएगा. एंड व्हाट अबाउट दिस रॉड? अगेन यू विल राइट दिस पर्टिकुलर इक्वेशन. M R क्रॉस VCM, इसको यूज करता हूं. आई एम जस्ट यूजिंग दिस स्पेस, है ना? इज इक्वल टू 0 प्लस M R क्रॉस VCM plus ICM omega. ठीक लिख रहा है? Yes or no?
Yes, sir.
Now, what will be M R cross VCM? So that value is equal to M VCM into perpendicular distance. यही तो होगा. बोलिए हाँ या ना.
Yes, sir.
भाई R cross VCM क्या होगा? R sin theta VCM and R sin theta is what? Perpendicular distance. यही होगा ना? You can make this angle theta. So this angle is also theta. So this will be R sin theta. And that is nothing but perpendicular distance. And what is ICM?
ML square by 3.
MA square by 12. Omega will remain omega. Now, what is perpendicular distance here?
A by 2.
A by 2. So M. And what is VCM? VCM we have calculated from there, isn't it?
Yes, sir.
So what is this value? M V naught by capital M, and that is A by 2 M A square by 12 omega. दिखाई दे रहा है ये आपको? Now you can see मैंने क्यों इसको अलग से लिखा था? Just you can see here. So what will be this value? M V naught A by 4 plus M V naught A by 2 must be equal to this M. This M is going to cancel out. So you have, मैं यहां लिख रहा हूं, M V naught A by 2 plus MA square by 12 omega. You can see this extra term is cancel out and you are getting exactly same thing. हो रहा है ये?
Yes, sir.
Same answer मिल रहा है ना?
Yes.
So you can take any point. You can take any point and your angular momentum of system is going to conserve. Because there is not any external force. Or external torque actually. Not force, torque. Okay? So you have to use this type of concept in a very nice way such that you can solve the problems. So I will stop here because it's already
Sir.
approximately 9.
सर
हाँ बोलो.
तो
R
सेकंड केस में जो लिया है वो एक और बार बताओगे?
सॉरी क्या बोल रहे हो?
तो जो सेकंड केस हमने लिया ना
हम्म
ऊपर वाला सेंटर ऑफ मास, वो
हम्म
एक और बार बताओगे? वो
एक
फॉर्मूला
और बार
कैसे
बता
आएगा?
देते हैं. डोंट वरी. अब देखो क्या हो रहा है. अब मैं इस पॉइंट के अबाउट एंगुलर मोमेंटम कंजर्व कर रहा हूं. ठीक है, ये तो क्लियर है ना? mv एंड परपेंडिकुलर डिस्टेंस इज दिस डिस्टेंस. क्लियर है ये?
हाँ यस सर.
a by 4 is this distance and a by 2 is this distance. So this is okay. ठीक है. अब आफ्टर द कॉलिजन ये तो जीरो हो जाएगा बिकॉज इट विल स्टॉप्ड. सो इसके कारण तो कोई भी एंगुलर मोमेंटम नहीं होगा. व्हाट विल हैपन टू दिस वन? इसको जरा देखते हैं. एम आर क्रॉस VCM प्लस ICM ओमेगा, यही तो आप लिखोगे डेफिनेशन. ऑलवेज यू विल स्टार्ट फ्रॉम देयर इफ यू आर यूजिंग द रिजिड बॉडी. क्लियर है ये?
यस सर.
Yes. Now, R cross VCM is M VCM and R perpendicular distance. R sin theta, isn't it?
यस सर.
Okay. And that perpendicular distance is this distance. And what is this distance? A by 2?
यस सर. यस सर.
Okay. And what is VCM? You have calculated VCM already from here.
यस सर.
है ना? So you can just put it here. And what is ICM? MA square by 12 into omega. So you have just put MA square by 12 into omega. And surprisingly, you will find that this value and this value will remain same because this omega, this M and this M is going to cancel out. So effectively, whatever be the extra term, it is going to cancel out. Isn't it?
यस सर.
So you can assume that your particle this rod is just doing pure rotation about center of mass. है ना?
Yes, sir. Got it. sir.
Okay.
सर
Yes.
प्लीज एक बार फर्स्ट केस में हमने आर बार क्रॉस वीसीएम बार 0 लिया वो कैसे?
इसलिए 0 लिया because this is your R and R and VCM is parallel to each other. ठीक है ना? एक्सिस तो यहां है ना? This is your R. Are you getting my point?
ओके यस सर फाइन सर.
Okay, so I will stop here. We will take some more questions in the next class, and also we will do some problem on torque. Okay, एक या दो class लगेगा, then we will finish this particular important topic. ठीक है?
Thank you.
चलो, thank you.
Thank you.
Okay, sir. Good night, sir.
Good night.